I apologize, but I've been running out of time every class, so if you need help on that class opener, please watch the video that I uploaded already. I want to jump right into the lesson here. I mean, we should all know how to find the vertex, the axis of symmetry. It's all review stuff, and I already made a video explaining that whole class opener. Right now I want to jump into notes 4.7, and the two things that we need to be very comfortable with are standard form and vertex form. As a matter of fact, by the end of this lesson, you'll be able to apply your knowledge of standard form and vertex form quadratics to graph, to describe transformations, and to convert quadratic equations from one form to another. So success criteria, you need to know both standard form, y equals ax squared plus bx plus c, and vertex form. You need to be able to know both of them, have them both memorized, and understand their differences. You also need to be able to describe how different a values affect the graph of its parabola. We should know that the a value, whether it's here or here, it's still a in both. And if it's positive, that means that the parabola would open up. If it's negative, that means the parabola would open down. And we also need to know if the a value is closer to 0, it would get wider, it would get vertically compressed. And the further it is away from 0, the narrower it gets, the more vertical stretched is what we call it. And of course, we also need to be able to derive the vertex from either form. It's really easy to find the vertex when it's in vertex form. It's more challenging to find the vertex when it's in standard form. So in standard form, how could you find the vertex? In order to find the vertex, which is a coordinate, you're going to need to know the formula x equals negative b over 2 times a. You guys remember that? Oh, yeah. And that only gives you the x value, right? And to find the y value, you plug in your x value and solve for y. So vertex form, it's really easy to find the vertex. It's simply h and k. So the vertex is a coordinate and simply h and k. So if I asked you which method would you, or which quadratic formula would you rather have, in what form? In standard form if I asked you to graph, or vertex form if I asked you to graph? What would you prefer? Vertex, hands down. Right? Vertex form is way better. Why? Because you could clearly see your h and your k. You already know your vertex. Okay. How about this? If you're, good question. H is the only one where you think opposite if you're looking at an equation and you want to find your x value of your vertex. Because of this minus sign, whatever you see right here, you think opposite. So if you see a minus 3, that's actually going to be a positive 3. If you see a plus 3, that's actually going to be a minus 3. Make sense? All right. Check this truth out. In order to write an equation of a parabola in vertex form, you need 3 things. You need the a, the h, and the k. Obviously, you need the a value. That'll be the number that's out in front. You need the h value that's inside the parentheses that's being subtracted from x, and the k value, the number that's being added or subtracted at the very end. If you have your a, your h, and your k, it's really easy to write an equation in vertex form. Look, let me give you an example of that. So let's just say I randomly told you your a value is 9, your h value is 7, your k value is 6, and I told you write an equation in vertex form. That'd be pretty easy, because the vertex form equation is y equals a parentheses x minus h squared plus k. So all you have to do is plug in your 9 right there, your h right there, and your k right there. So your equation would be y equals 9 parentheses x minus 7 close parentheses squared plus 6. That's your vertex form equation. So as you can see, it's super easy. If you know your a, your h, and your k, it's really easy to just take that a, put it right there where the a belongs. Take the h, put it right there where the h belongs. Take the k, put it right there at the very end where the k belongs. Easy, right? Okay, so knowing that fact, that if you have your a, your h, and your k, it's really easy to write your vertex form equation. We'll be able to convert standard form equations into vertex form equations. Okay. What do we need to write a vertex form equation? A, h, and k. You need those 3 things, the a, the h, and the k. As a matter of fact, turn to somebody right now and let them know. To write a vertex form equation, you need 3 things, the a, the h, and the k. Go for it. That's right. Okay, guys, back up here. So, ladies and gentlemen, do they give us an A? Yeah. Guys, remember, down here, the A value is simply the number in front of the x squared, and it's the same down here, right? So the a value, they actually give that to you. It's up here. The a value happens to be 1. So you can put 1 right there for a, so we know a. Now, I don't see an h and a k, but I know that I could get that h and k from my vertex, all right? So my vertex, which is a coordinate, will provide me my h and k value. So how do I find my vertex on any parabola? So to find the vertex of any standard form quadratic trinomial equation or any standard form equation, you're going to use a formula. The formula is x equals negative b over 2 times a. And when you use the formula, of course, use parentheses when you plug in. So your b value is 10, and your a value is 1, right? So 10 and 1. So you're plugging in a 10 right here and a 1 right there. So this formula, it does say x equals, so this will give us our x value of our vertex. That'll be a negative 10 over 2, which is negative 5. Are you with me? So the vertex x value is negative 5. Technically, you already have your h, because your h is the x value of your vertex. But let's just keep going. Once I have my x and I need my y, what do? Plug it back in, right? Plug it back in. So my original equation is y equals x squared plus 10x plus 20. And I hope you notice that instead of me writing x's, I put parentheses. Because I know that my x value is negative 5. I got that from the formula, negative 5. All I need to do now is plug in that negative 5 right there and right there. So let's do that. Let's plug in the negative 5. And we'll do the math and we'll find what the y value of our vertex is. Doing the math, we get positive 25 right here with the minus 50 with the plus 20. From left to right, 25 take away 50, that's negative 25. And negative 25 plus 20 is negative 5. Negativo 5, that's right. So our vertex y value is negative 5 as well. So our x value is negative 5, and in this case, our y value happened to be the same exact thing. But we know now h and k. So our h value really is negative 5. Our k value really is negative 5. So we could plug it all in. Whoops. We could plug it all in to our vertex form. Vertex form is y equals a parentheses x minus h squared plus k. All we need are those 3 things that we just found. The a value is 1. The h value is negative 5, which of course is going to become plus 5 because the minus minus changes to plus plus. And then plus k, well, the k value is negative 5, so we're just going to put a minus 5 out here. And of course it's y equals in front of this whole thing. So there's your vertex form equation. Now keep in mind, guys, this standard form equation, if you were to graph it with the graphing calculator, it'll give you a parabola that opens up with the pattern 1, 1, 2, 4, 3, 9 that has the vertex at negative 5, negative 5. If you graph this one, it also has a vertex at negative 5, negative 5, and it also has a pattern 1, 1, 2, 4, 3, 9. Why? Because it's the same exact parabola, identical parabola, just a different form. So that's what we're doing on today's worksheet. We're simply taking any equation and rewriting it in vertex form. So standard form is nice, but vertex form is nicer, so we're going to be able to switch them from standard to vertex. So how would I rewrite this one in vertex form? Well, you need those 3 things, a, h, k. What do we know so far? A is 3. And the h and k, we're going to find the h and k by finding our vertex. The h will be our x value of our vertex. The k will be the y value of our vertex. We're going to use the formula x equals negative b over 2 times a, negative parenthesis over 2 times parenthesis. So that's really a negative 6 inside of the parenthesis over 2 times 3. A is 3, b is negative 6, c we don't care about. It's not in the formula right now. So doing the math, we're going to end up with positive 6 over 6, which is 1. So the vertex has an x value of 1. How do I find the y value once I already have the x value? Plug it in, right? So let's rewrite our entire equation. Y equals 3x squared minus 6x plus 5. Again, I replaced x's with parentheses. Why? So I could actually plug in my 1 right in there into both of them. So we have a 1 right here and a 1 right there. Let's do the math quickly. 1 squared is 1. 3 times 1 is 3. And then 6 times 1 is 6, but there's a minus sign between it. And last but not least, let's bring down that plus 5. So from left to right, 3 take away 6 is negative 3. Negative 3 plus 5 is positive 2. That's our y value of our vertex. So now that we know x and y of our vertex, we actually know our h value of 1 and our k value of 2. Once again, h value is 1, k value is 2. So now that we know our a, our h, and our k, we could plug it all into y equals a parentheses x minus h squared plus k. So let's do that. It's going to be y equals what? 3, open parenthesis, x minus 1, close parenthesis, squared plus k. What's k?
2.
Plus 2. And we're done. That's your vertex form equation. Guess what would happen if I were to take this binomial, x minus 1, and multiply it with itself, distributing? I'd get a quadratic trinomial, and then I would distribute the 3 into each term of the trinomial, and then add 2 to the c value at the very end, and it would take me back to the original standard form quadratic. Okay? So just, again, let me repeat. This equation is this equation. It's just in a different form. It's kind of like having some clay and changing the shape of it, right? Change this to this, but it's the same exact parabola, same everything. It's just a different form, just looks different. So this is what we're doing on all of our questions on our homework today. Would you guys like to try number 3 on your own, or just have me continue explaining? Go to number 4?
Yeah.
Okay, you guys can handle number 3, right? Same exact process. Let's go to number 4. So number 4, same exact process. What are the 3 things that you need? A, H, K. What's our A value?
2.
Okay, great. Now our h and k, we're going to find it by finding the vertex. Okay, and the vertex you're going to find by using the formula x equals negative b over 2 times a, which is negative parenthesis over 2 times parenthesis. What's the b value? 0, right? The a value is 2. The b value is the term in the middle, and there is no middle term. The c value is 2. So the b value is 0 because there is no bx term. The a value is 2, so you end up with 0, negative 0, which is still 0, divided by 4. 0 divided by any number is what? 0. So our vertex x value is 0. Our y value, we need to find by plugging it back in, right? So let's rewrite the equation. Y equals 2x squared plus 2. And let's actually plug in that x value of 0 right in there. And what do we get for our y value? 0 squared is 0, 2 times 0 is 0, but 0 plus 2, y equals 2. So your y value is 2. So your vertex is 0, 2. 0, 2. Now that we know a, h, and k, now we could write it as a vertex form equation. Y equals a parentheses x minus h, close parentheses squared plus k. So you have y equals the a value is 2. Open parentheses x minus h. What's h? 0. Close parentheses squared plus k. What's k?
2.
Plus 2. So this is your equation.
Would we have to write that minus 0?
You don't have to write the minus 0. I would,
So,
just to keep it in the form.
yeah, but then if we didn't, wouldn't it be the same thing as?
Exactly. So I would leave it as a minus 0. See, and I don't want to ruin things, but if this is a process, you need A, you need H, and you need K, right? But is there other ways of doing it? Sometimes there is, right? In math, there's many roads to the same place. So you could have looked at this one and said, you know what? I'm going to forcefully look at, instead of, are you serious? Okay, sorry. Instead of looking at it as ax squared plus bx, there is no bx plus c, you could forcefully look at it as a vertex form equation. See, a vertex form equation has the a out in the front, and we know that a is 2, but then it has parentheses with the x minus h on the inside with the square on the outside. So you could forcefully put parentheses around that x. And then you would say, what is your minus h that's in here? Since there is nothing being subtracted, what's your minus h in there? 0. So you could forcefully rewrite this right off the bat. Y equals 2 parentheses x minus 0 squared plus 2 at the very end. And that's your vertex form equation right there. If you wanted to, right? I mean, there's probably a different way on each one of these. Like on this one, you could, if you wanted to, mess around with factoring. I mean, it's not always going to work, but like what would happen if I would pull out a 2? What would be left? X squared plus 6x plus 9. And believe it or not, that blue quadratic trinomial is a perfect square quadratic trinomial. That's a perfect C value of 9, which means I'll be able to write it as a binomial squared with x right here and simply half of b right here. And then that a value would just come down, and guess what? That's already in vertex form. I mean, you could have done what we always do, say, okay, find A, find H, find K by finding your vertex using the formula. The A value is 2. You could clearly see that the A value is 2 right there. But use B, the 12 for the formula, and you could find H and K, and you would get to this anyway. Okay. If you did find the formula, it would be -3, 0. So there's always other ways, or not always, but there's many times other ways of rewriting it in vertex form. For number 1, I could have completed the square to get this perfect square binomial, to get this equation. But I don't want to confuse anybody, all right? Let's just stick with it, the fact that if you know A, you know H and K, you'll be able to write your equation. Yay? Okay. Let's move on to our worksheet. So here's our worksheet. We're only doing 1 through 6, skipping 7, 8, 9, and we're also skipping 12. But right here on the rest of this video, I want to focus in on 10, 11, 13, and 14. So if you know both forms, it's pretty easy to graph. Which one's easier to graph, number 10 or number 11? Number 10 is in vertex form, number 11 is in standard form. 10 is way easier to graph. Why is that? Because you already could identify your A value of 1, your H value of 3, and your K value of -1. Actually, your H value is -3. You got to think opposite of what you see on H. So when it's in vertex form, you could easily see your vertex being -3, -1. And that's a heck of a lot faster than calculating your vertex using the formula when it's in standard form. So -3 on the x, -1 on the y, that's right here. You also need an axis of symmetry going right through that vertex. That would technically be x equals -3 if you wanted the axis of symmetry equation. And is this parabola opening up or down? Up, because the A value is 1. Is it wide or is it narrow, or is it a regular U-shaped curve? Regular U-shaped curve. What's the pattern when your A value is 1? 1, 1. So put a dot right here. Then you go back to the vertex, 2, 4. Put a dot right here. And then 3, 9. 1, 2, 3. 9's way up here. Again, when your A value is 1, you're able to use the pattern 1, 1, 2, 4, 3, 9. And of course, with that axis of symmetry, you could reflect them over to the other side, and boom, we're done. I mean, graphing vertex form equations are amazingly easy and quick. Sorry, that wasn't the best graph, but there's your parabola right there. So you guys could do number 11. The only difference is you cannot visually see your H and K because it's in standard form. So on this one, yeah, you're going to have to go x equals -b over 2 times A. Use parentheses when you calculate it out. Once you find that x value, plug it in to find your y value, and you'll have your vertex, and then you graph the rest exactly the same. So I'll leave you number 11 to do. You guys should be all right with that. The answer is on the back. But I really want to spend the last moment of this video doing the last 3 questions, all right? Or at least some of these, maybe 13 or maybe 15. I don't know, what do you guys want, 13 or 14? 13, why not? Okay. So it says write an equation for a parabola, and they give you a couple of things. They give you a vertex. So if they want you to write an equation, which form are you going to pick? A standard form equation or a vertex form equation? Especially if they give you the vertex. Vertex form, right? Okay. So let's write an equation in vertex form, especially because they give us this vertex right here. So you're going to have to write really tiny, or maybe write it again in your notebook. But I am going to write my equation in vertex form. Y equals A, parentheses x minus h, close parentheses squared, plus k. They want us to write an equation. I'm going to write it in vertex form. Why? Because all I need to write an equation in vertex form are three things. What are those three things? A, H, K. All right. What do they give us? Do they give us a equation where you could see the A value? No, they don't. So we don't know A. That's a problem. Could we at least see H and K? Yeah, what's H and K? H is 1, K is 3, the vertex, right? The vertex gives you your H and K values. So H is 1, K is 3. Bless you. So guys, we have 2 out of the 3 things that we need. We need that A value. And math is beautiful because whenever you're missing something, usually you could take what's provided to you, plug it in to find out what you're looking for, right? So they do give us an H and a K. What else do they give us? A point, a coordinate, which is really an X and a Y value, okay? So what we're going to do here is take the H, the K, the X, and the Y and plug all 4 values in. Okay, once again, Y equals A, parentheses, X minus H, close parentheses, squared plus K. I want to plug in my H right in here, my K right over here, my X right here where the X is at, my Y right here where my Y is at. I want to plug in everything that they give me. That way I could find that missing value of A that I really need to write this equation. So instead of Y, what am I going to plug in? Negative 15, good. Equals, what's my A value? We don't know, so I'm just going to leave it A. Parenthesis, X, wait, what is X? Negative 2. Minus H, what is H? Minus 1, close parenthesis, squared, plus K. Do we know K? Plus 3. So you see we plugged in the H, the K, the X, and the Y, and now we have an equation that we could actually solve for A. So let's start doing this. What is negative 2 minus 1? That's negative 3, right? You owe 2, you owe 1, you're going to owe 3. So you have negative 3 squared. What's negative 3 squared? That's 9. So I really have a 9 plus 3, but there's the multiplication of A that comes down. A times 9. So obviously you have to multiply before adding. Don't add 9 plus 3. That would be incorrect. So what do we have so far? We have negative 15. Let me rewrite it. Negative 15 equals 9. A times 9. A times 9 is simply 9A. Plus 3. So now I have an equation that I could actually solve for A. I subtract 3 here, subtract 3 over there. I will end up with negative 18 equals 9A. I need to get rid of that 9. So what do? Divide by 9, divide by 9. So I really have my A value equaling negative 2. So once again, ladies and gentlemen, I took my H, my K, my X, and my Y, plugged it all in to find my A. And now that I know my A, which is negative 2, I'm able to write my equation with my A, H, and K. So here's my answer. Y equals A, negative 2, open parentheses, X minus H, which is 1, squared, plus K, which is 3. So once again, take what they give you to find out what you need. Plug it all in and find out what you need, which is the A value. Then you'll be able to write it. You're going to do the same exact thing with this last one, number 14. Okay, so number 15, you will have to do on the homework, and it is a real world type of problem. It's talking about a baseball, right? So when somebody hits a baseball, it goes up, reaches a max height, and then it comes back down. Now this equation, it's not in terms of Y equals X values. It's in terms of H of T, which means height, is calculated by plugging in the appropriate time into T. And the T is by seconds, if you read this problem. So let me ask you this. Before this person hits the ball in the air, at 0 seconds, before he hits it, how high from the ground is the ball? And how high is that? According to this parabola right here. At 0 seconds. Remember, T is seconds. 3, right? So this guy is holding the ball 3 feet high before he even cracks that ball with the bat. Make sense? Okay. Now, So he's at 3 feet high, and then he's going to hit it, and it's going to travel up, 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 maybe like 1 second, 2 seconds, 3 seconds, and all of a sudden it's going to come back down, right? So this is based on seconds with the t right there. So the question is, what is the maximum height? So what does that really mean when they ask you for the maximum height? The maximum, which is found with the vertex, right? So let's all find the vertex, which is an x and y value using the vertex formula. X equals negative b over 2 times a. Negative b, what's the b value? 80. What's the a value? Negative 16. So if we did this correctly, we'll get negative 80 over negative 32. And when you do that on a calculator, you're going to get positive 2.5. Now remember, we're not talking about x's here. We're actually talking about t in seconds. So the vertex is 2.5, the x value, the seconds. So after 2.5 seconds, the ball reaches its maximum height. So let's say here's the ball. He hits it 1 second, 2 seconds and a half, and then it comes back down. All right? So that's not the question, though. It doesn't say after how much time. It's saying what is the maximum height. So once you already have this x and you need the y, what do? Plug it back in. So let's plug it back in to this function. Remember, it's 2.5 seconds. So let's rewrite it with parentheses. And inside the t position, we're putting in the seconds, 2.5, that we just found using the vertex formula. And if you type all this exactly the way it is into the Casio calculator, or into any calculator for that matter, you will get the final answer of 103. So that's your maximum height. So this guy hits the ball right here. After 1 second, 2 seconds, 2.5, it reaches max height, then it comes back down. So this location, this max value, is at 2.5 seconds, and it's 103 feet high. Okay. So the answer to this, what's the max height? You would say the max height is 103 feet. At what time? At 2.5 seconds. Okay, I'm done. We need to finish up this worksheet. So let's do it.